also doing. Does it make sense? This is a search algorithm, and I know it is a repetitive process. We exit when the value is confirmed in the array, or we confirm that the array the value is not in the array. Does it still make sense, even though this is now binary search?
Yep.
Still makes sense. Okay, so that is why it is important to kind of describe it in kind of vague terms first, because it really captures the spirit or the objective of the algorithm itself. And then the next revision is going to be pretty much the same thing. We have to define certain names. Okay, so we define, array A is the array that may contain the value. The value we are looking for is in variable K. So in the second iteration or the second revision, we can now say the value is confirmed in the array, which means for some array element in the array, in this case we don't use I, could have used I, but M makes more sense in this case. So I would say when A bracket M for some M, I don't know how I get to this M, but if I can confirm that A bracket M does equal to K, then I can exit the loop. Yep.
Why does M make more sense?
Midpoint.
Oh. Sorry. Yeah.
But that's but that's because I already knew what the algorithm is going to do, to name it M. But we don't quite know how to express the second part yet. How do I know the value is confirmed not to be in the array? Let's just say that we don't know how to express that at this point. We'll call that another, this already another revision. So now we move on to revision 3. Revision 3 is going to take a closer look at how do we get M? How do we do something like that? So the biggest question is, how do I represent, okay, in the case of this example, how do I represent initially that the entire array may contain the value K? After the first comparison, how do I represent the fact that A bracket 0 up to A bracket 3 cannot have the value K? After the second comparison, how do I represent that only A bracket 4 may contain the value K? That's the question. It is a representation question. How do I track the region of the array that may still contain the value K? Well, let me ask you a question. Is that region of the array that may still contain the value K, is it one single contiguous region, or can it be broken up into fragments?
It's contiguous.
It is always contiguous, right? We initially start with this much. Each time we compare, we either move this end or this end closer, and so they get closer and closer to each other. Is that making any sense? But it is always contiguous. Now, any region that is contiguous means that you can remember what the region is by remembering what is the beginning and what is the end. Is that making any sense? Because it is contiguous, all you have to do is to remember this is the beginning of that region that may contain the value K, and this is the end of that region that may contain the value K. So this is a big step from revision 2, because now we can introduce a variable B. B represents the index of the first element that may contain the value K. And we'll use E to represent the end. E represents the index of the last element that may contain the value K. Now that is a big help, because now we actually can have variables to represent the region that may still contain the value K. Knowing these two, B and E, do we know how to compute M in this case? Okay, how do we compute M?
Subtract B from E, divide by 2.
Okay, very good. So it is also the same as B plus E, the whole thing divided by 2.
Yeah.
Boils down to the same thing. Yep. Now, some people may ask, yeah, but sometimes this is a fractional number. How do we deal with that? We can deal with that later. We want to capture the general idea first. The details we can defer until later. Okay, so this is a big step, because we introduced B and E, and not only that, we also relate M to B and E. And I would call this another revision. If A or E, it is still important because now we know how do we represent the region of the array that they still contain the value K, and how the index of the variable that I'm comparing to K, how does that relate to B and E? So this is a very important step. And every time I have a major change to the algorithm or major addition to the algorithm, I make it its own revision, and then we move on. Now this is great, but it is not complete. In other words, if A bracket M does not equal to K, it goes back to the beginning, and M gets recalculated. But since we are not changing B or E, it will be comparing to the same element again and again and again, in which case it's not going to be very helpful. When you look at the example that we did by hand, you can remember that after one comparison, we always do something to eliminate either the left-hand side or the right-hand side. So it sounds like that we need to at least perform some comparisons first, right? And depending on the result of the comparisons, we may do different things. So what we do this time is we copy this algorithm, and then we say we compare that. Okay, we say A bracket M is less than K, then we do something. If K is less than A bracket M, then we do something else.
Is that considered a subroutine?
No, it is not a subroutine. This is really just a framework of a multi-branch conditional statement. It's not a subroutine. It is just a multi-branch conditional statement. I have not yet stated what to do when the condition is true, but I know I have to look for those specific conditions, because we know that when it is less than, we eliminate one side of the array. When it is greater than, we eliminate the other side of the array. So I know that we have to do different things depending on the result of the comparison. When you compare two values, you have three potential results. One is less than, one is greater than, or they are the same. So that's why we have an else here to potentially specify the logic of what do we do when they are exactly the same. Okay, if there's nothing to do, we can just leave it empty and optimize it out later on. Are there any questions about the framework of the conditional statement, and why the framework of why the multi-branch conditional statement has to be after we assign a value to M? I used the wrong symbol for assignment. Should have used the left arrow. So I want to change that back to the left arrow. Any questions at this point? No questions. Okay. If there are no questions, then we can go ahead and try to answer this particular question here. If A bracket M is less than K, like in this case in our example, what are we going to do? Abstractly, what do we want to do? We want to say A bracket 3 and everything before that should be eliminated. That's what we want to do. That's what we want to represent. Yep.
We should then redefine A bracket M as being B plus 1.
We don't want to redefine A bracket M. We don't want to change the value 10 to something else. Right. We want to change the index.
Right. That's what I meant.
Okay, so we want to change B, right? Because B is the index of the first element that can still have the value K.
Right.
Now, the most intuitive way is to say B gets M, because M is here, and we want to go from the beginning to here to represent the region of the array that can still have the value is from here and on. But that is actually incorrect, because we already know that M itself cannot be the index. Exactly. So we have to move it off by 1. So B plus 1.
B plus 1.
Yeah, B plus 1, because the next one may contain the value that we are looking for, but this one we know for sure does not have the value that we are looking for.
Middle. Middle. Okay.
Yep.
I thought you said B.
That was B. Now, how about the other case? What happens when the element has a larger value than the key that I'm looking for? E equals M minus 1. Okay? What about when they are the same?
You're done.
I'm done. All right. So there's nothing to do here. There's nothing to do in the conditional statement because the conditional statement is in the loop. And the loop has an exit condition of A bracket M equals to K. So that will take care of getting out of the array when we have found the element. So that means there's nothing to do in the conditional statement at all when the two values are exactly the same. Are we doing okay so far with the logic of this code? Okay. And we'll call this one revision. And now we are moving on to revision 5. In revision 5, we have some minor details to take care of, particularly how do I know the value is confirmed not to be in the array? Because we have yet to answer that question. What variables do you think will be helpful to answer that question? B and E. So B initially is all the way over here, E is initially all the way over there. In one comparison, they get closer, because we are reducing the region by half. In another comparison, they get closer, 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 closer. Yep.
Maybe when B is not M plus 1 and E is not M minus 1.
But that kind of flows with M. M is not involved to determine whether we can exit or not. Okay, think about this. Now B is starting all the way at the beginning initially. E is starting at the end initially. In one move, either one will come close. They will come closer. With every comparison, they get closer and closer, which means at some point they might be the same value. So the question is, when B equals E, is that an exit condition? What does it mean when the index of the first element of the region is the same as the index of the last element of that region?
You only have one.
We have one left. Okay, so we cannot exit when B equals E. So that means we should exit when they cross over. Okay, so normally B is less than E, 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 B is less than or equal to E, B is greater than E. Okay, so when they cross over, when B is greater than E, it signifies that we have nothing left. Okay, so we can change that to B is greater than E, and that represents when the value is confirmed not to be in the array. And if you look at the definition of B and E, it makes sense. Okay, because if you look at the definition, I need to tie my shoelace before I trip. That would be a scene that you don't want to see.
YouTube.
YouTube, yeah. So when B is greater than E, if you just think about the definition of B and E, this is also making sense because B is supposed to be the first element, the index of the first element of a region that contains the value K, and E is supposed to be the last one. So what happens when the first one is already going past the last one? It makes no sense, right? So from multiple ways of looking at this, B is greater than E should represent the value is confirmed not to be in the array. Okay. And we have one last, but we have two more, business to take care of at this point. It is helpful to reflect the result of the search. So how should I say found? Found is my variable to reflect whether the value was actually found. What should it be? We can either do that, or we can say B is still less than or equal to E. Either way works. Yep.
E is less than